Okay, so in the lecture part 1, for lecture 2, we learned about a lot of examples on exponents and radicals. Now, we will build from there, and we have some more examples that is related and that might be helpful in doing actual homework questions. Now, and also you might see some things coming from lecture 1, so that's how things work, everything build up. So right now let's see, this you could have done from lecture 1 material. It's negative 2 to the third power, and because of the parenthesis, this, everything goes in like negative 2 times negative 2 times negative 2, which is negative 8. But in the second case, you can see the negative sign is outside of the exponent. It doesn't belong there, so it's just one negative, and 2 to the power 3 is 8. Now the answer is both answers are negative 8, but you came to the answer in two different ways. In one case the negative sign belonged to the exponent, and in the other case it did not. Okay, now let's see this third example right here, and you can see that it's a negative number inside, and if you look at the exponent, it's a fractional exponent, which means it's a root, and further it's an even root. So we have an even root of a negative number, which is bad. So it's an even root of a negative number, which is not a real number. So we can just say not real. Now we can use that excuse and say the answer does not exist or the answer is not real until we learn complex numbers. After that, you can just say this is actually 4i, but right now it's not real. Now the difference of the next example is that the number, the negative sign does not belong. There is no parenthesis. It's outside, so you just keep it. And 16 to the power 1/2 is the same as the square root of 16, which is 4. So what we have here is just 4. So the answer is negative 4. And again, I emphasize the difference is where the negative sign is, and is there a parenthesis or not. That's saying it belongs there. Okay. Now, the next one. Here again we see a square root, and you see something negative inside. So is it a square root of a negative number? Let's see. It's a square root, but you have negative 5 squared. Negative 5 squared is negative 5 times negative 5, which is plus 25. So we are looking for square root of 25. And as I mentioned in class, when I say square root, it should be the positive value or the principal square root. Okay? So this one right here is just 5. Okay, and the other one is the cube root of negative 4 to the power 3. And when it comes to odd roots, this weird thing of negatives becoming positive, that doesn't happen. Okay, so we don't really worry about that. It's actually negative 4 to the power 3 cube root, which is just negative 4. Okay, so let's move on to the next page. Now this one is something we discussed in the class. The square root of a squared is absolute value of a. So that is something that you need to consistently worry about in this class. And how would you feel, or how would you see how a general rule that I can use in each case? Now the general rule is, so what I do here, taking things out of a square root, I call it pulling something out of a square root. Okay, and sometimes, as we've seen in the class, we pull something out completely, and sometimes we just pull some portion out. For example, if I have square root of a cubed, I can write this as square root of a squared times a to the power 1. Then I can pull this out from the square root and make it a root a. And you can see in that example, I did not completely pull out that a from the square root because there is something remaining still in the radical. Okay, so that's one tiny little detail. So let me just write down the rule. If you completely pull out a variable, if you completely pull out a variable, so that matters. Completely pull out a variable from an even root, and once you pull out, what's remaining has an odd exponent. So if you completely pull out a variable from an even root, and what you have outside has an odd exponent. Use the absolute value. Now that's the complete general rule of when and where to use the absolute value. Okay. Now this, I look at this question as a source of true-false questions. For example, I can ask the sixth root of a to the power 6, is it a or is it absolute value a? So in that situation, you just need to remember the statement and use this statement to decide whether it's true or false. Now let's see how these examples work and how these examples does not work. Now look at this guy. We are looking at a square root of a to the power 4. Now you know when you take the square root of a to the power 4, that would end up, you completely pull it out, and you would have a to the power 2. Now, if it was a square root, so it was an even root, and you pulled out it completely. But what you have here is an even exponent, but it's not an odd exponent, so you don't have to use absolute value. The answer remains as a squared. Now let's look into the second one. So a to the power 7, and you take the sixth radical or sixth root. So what I can do is I can split it. Well, how do I split it? A to the power 6 plus 1 is 7. And then I can write it as a to the power 6 times a to the power 1. And now I can pull this guy out and write it outside as a single a. So 6 root of a to the power 6, that would be a root a. 6 root of a. Now in this case, I did not completely pull out a because there is some part of a remaining inside the radical. Therefore, I do not use the absolute value. Okay, so one more example to show you where I would use the absolute value. Let's say the example number 3. Let's say the fourth root of a to the power 12. This is a completely new example. It's not in the lecture notes right now. You can just write it down. Now let's see how you pull it out. So fourth root of a to the power 12. 12 divided by 4 is 3. So you take out a to the power 3. And as you can see, you took the whole thing out. So now it satisfies this statement. You completely pulled it out from an even root, and what you have here is odd. Therefore, you need to use the absolute value. So the answer for this is absolute value of a to the power 3. So I believe that together with doing more examples should make you familiar with this new concept, and make sure you check it always when you have an even root. Okay. So now let's look at some examples and see how we can go about doing it. But before that, let us go to a question. Okay. Now we have simplifications. So again, the way I do here is not the only way to go about. Okay, you can. There are multiple ways. There are different orders depending on how comfortable with you are with these methods. The way I use is not the only way to go about that. So let's see. So first I would do is I would just work inside, distribute this -1 into all of them. So I no longer have parentheses here. And also I would distribute this -2 to all of these exponents, so I no longer have parentheses there. So what I have here on the top is 3 to the -1, a to the -1, b to the -1, and c to the -1. And here I have 2 to the -2, a to the -4, b to the -1 times -2, and c to the 3 times -2. That's how exponents work, as you've seen in class. And that would be, well, now because I can see that there are some exponents which are negative on the top and some exponents which are negative on the bottom. Let me just rewrite it really quickly. So that would be 3 to the -1, a to the -1, b to the -1, c to the -1, 2 to the -2, a to the -4, b to the 2, divided by c to the -6. Now, all the things with negative exponents should switch their sides and they should become positive. So, 3 on the top will become 3 in the bottom. So, 3 to the 1, a, b, c. And here, let's have a 1 as a placeholder. This 2 should go to the bottom, so 2 squared. This a to the -4 should go to the bottom and become a to the 4. b to the 2 stays there because it's positive. And c to the -6 would go to the other side, which is the top, and will become c to the +6. And you can now simplify it. So c to the 1 is here, that goes off with the c to the 6, and you will get c to the 5. Okay? And then you have 3 times 2 squared, that is 12. And these two will combine and become a to the 5. And then lastly, this b and this b squared, you can just cancel off 1b, so you get it. So it's bc5 over 12a5. You can see there are some homework questions like this, so you can try things for yourself, how to work with these exponents. Okay. Yeah. Let's go ahead and simplify this one right here. Again, my strategy would be first removing the parentheses. So I would distribute all the exponents. Now I'm going to do it in a single step. I will just do it right here. Okay, because it looks like I don't have enough space. So that would be, so I'm going to multiply all these exponents by 2, and I'm going to multiply all these exponents by by 4. So what I get is 3 to the negative 2 a to the 4 over b to the negative 6 times 3 to the 4 b to the negative 8 divided by a to the 4. And this time I will take a slightly different path. You can go by, you can just move the negatives to the bottom, positives to the top. Also, I mean, either way, you have to go and use the easiest way possible to do these examples. Now, in this one, I would sense that here, I have the same base, I can just subtract the exponents. So take 3 to the power negative 2 times 3 to the power 4, that would be 3 to the power plus 2. You just add the exponent. And a to the power 4 on the top cancels with a to the power 4 on the bottom. Okay, so the only thing that's remaining is bring this guy up, so that would be b to the power negative 8 that was remaining, and b to the negative 6 when it comes to the top becomes b to the plus 6. So that would be 9 b negative 8 plus 6, that is 9b negative 2, or 9 over b squared. Because the question asked you to keep all the exponents positive. Okay, now let's go to a question. I will pose one of those, something similar to one of those questions. Please do the question and select the correct answer. Okay. Alright, coming back to radicals, let's do some radical questions. Now, again, the rules we learned just in the previous page applies here. And okay, like right now, right here, because it's an odd root, there's no worries about the absolute value. So just forget about this for this question. And my strategy here will be looking at the root, which is the third root. So I'm going to regroup these, and you will see how do I do that regroup. So because I see a to the power 4 is a to the power 3 plus 1. Now why did I break it to a to the power 3 plus 1? Because I have the third root on the outside. So if I can take third root of a to the power 3, that will just be a. Okay? Now, similarly, I can break this guy to b to the power 9 plus 2. So what you're doing here is one portion should be a multiple of 3 and the other one should be just a number that's remaining. So I could have done 6 plus 5, but 9 is bigger than 6 and 9 is the optimal number that I can use here. Okay? And also C6, well, that's just C6. Okay, and that can be split as a to the 3, a to the 1, and this can be split as b to the 9, b to the 2. And I'm going to write this, and this. So let's see. So this is the same as the third root of a to the 3, b to the 9, c to the 6 times a to the 1 and b to the 2. So that's what's remaining. And these are the multiples of 3. So now you can see it's very beautifully written. You can pull things out from the cube root. So what you get here is cube root of a to the 3, just a. Cube root of b to the 9, that's b to the 3. Cube root of c to the 6, that's c squared. And what's remaining inside is ab squared. Done. Okay, now the next one you have to be careful because it's an even root. Okay, so this is an even root. So let's just be careful about the absolute value. Now a to the 4 is just a to the 4, just keep it like that. B to the 8 is Well, again, 8 is a multiple of 2, multiple of 4, so it's fine. Now c to the 5, I will split it as c to the 4 plus 1, because 4 is a multiple of 4 and 1 is a remainder. And this can be further written as c to the power 4 times c to the power 1 by using the properties of radicals, exponents. Now you can just combine them in a nice way, so you can see that how things cancel off. Okay, so the same radical would be the radical of 4, a to the power 4, b to the power 8, c to the power 4, and c to the power 1. Now the first three you can actually pull it out from the the fourth root. So that would be a, b squared, c, and fourth root of c. Now this is the point where you have to worry about the absolute value. Now look at what happened to a. Now it was fourth root of a to the power 4. So it was an even root, and you pulled a out completely because there are no a terms remaining in the radical. So it was pulled out completely, and what you have has power of 1. Therefore you use absolute value. In b, you completely pulled b out, okay? But what's outside has even exponent, therefore you don't use absolute value. You don't use absolute value because it's an even exponent when you pull it out. Now, if you don't understand it, watch and rewatch this, and again do a lot of homework questions until you understand this idea. Okay. Now, the last one is C. We did not completely pull C out because there is one C remaining here in the radical. Okay, so we don't use the absolute value. So the correct final answer should be absolute value of A, B squared, C, and the fourth root of C. I hope at this level you should you understand what went on right there. Okay. The next one is combining radicals. So combine the following radicals. Again, and now you can see the square root does not seem to add up because they are two different numbers. But if you look closely, you can see that 125 is the same as 25 times 5. And 20 is the same as 4 times 5. So let us write, instead of 125, I'm going to write square root of 25 times 5. And instead of root 20, I'm going to write square root of 4 times 5. Now I can take out square root of 25 and take out square root of 4. So I get 5 square root of 5 plus 2 square root of 5. Now it looks like 5x plus 2x, which is 7x, or 5 square root of 5 plus 2 square root of 5, which is 7 square root of 5. The next example is very similar. The only thing is we have a to the powers again. The trick is write things down the way you want it. Okay? Now a to the 3 can be written as a to the 2 times a to the 1. Now 64, a to the 7 can be written as 64 a cubed, a to the power 6 times a to the power 1. Have a good look and see what I did there is correct. Okay, now let's write it down in this form. So this one would become 64 a to the 6 a to the 1 plus square root of a squared a to the 1. and you can see that you can pull this out of the square root. 8a cubed root a. And you can pull this out from the square root. That would be a root a. Now you can see root a is a common factor, so you can take it out. 8a cubed plus a. And well, at this point that would be a final answer. Well, of course, you can take a as a common factor and take it out again. Sometimes we are, I mean, if it's an exam question and this answer is not the final answer, and I have a different choice containing square root of a times a, 8a squared plus 1, that's the correct answer. So you should be able to identify which one is the correct answer and how further I would factor things. Okay, so this is all right. This is a good answer. Okay, and probably the last thing we are going to do, not the last thing, rationalizing the denominator. So let's look at that. So once I do the rationalizing the denominator thing, I'm going to ask you one more question. Okay, so let's see what we have here. Just rewrite this. 3 and cube root of x squared is the same as x to the power 2 over 3. Okay, now rationalizing means I need an integer here. I need an integer. So I have right now 2/3. I need to make it as an integer, and all I need is to add 1/3, which means I would multiply the top and the bottom by x to the power 1/3. Remember the multiplication of, you have to multiply the top and the bottom. So x to the power 1/3 goes in the top and the bottom. And what you have here is x to the power 1/3 on the top and 3 x to the power 2/3 plus 1/3 and x to the power 1/3, and here you have 3x. Okay, now the whole point of rationalizing the denominator is you should have something nice in the denominator which is not a fractional exponent. All the exponents in the denominator should be integer values. Okay, that's the whole point. Now you can see all the exponents in the denominator are integer values, which means you're good. Okay, the same principle applies in the second example as well. Let me rewrite that. I have 2 to the power 1/3 and x to the power 5/3. Now again, the whole point is you should have integers exponents in the denominator. So let's see what's missing. 2 to the power 1/3. I need to make this an integer, so I would multiply that by 2 to the power 2/3, because 1/3 plus 2/3 becomes 1. And x to the power 5/3, if I multiply by x to the 1/3, that would become 6/3, which is an integer, which is 2. So if you do it to the top, if you do it to the bottom, you have to do it to the top. So now let's write down what we have here. 2 to the 1/3 plus 2/3, x to the 5/3 plus 1/3, and 2 to the 2/3 x to 1/3. Now have a good look at what I did right there. Okay, and so at the end we will add them. 1/3 plus 2/3 is 3 over 3, which is just 1. 5/3 plus 1/3 is 6 over 3, which is x squared. And then on the top you have 2 to the 2/3 x to the 1/3. And that would be the final answer, because the point of rationalizing the denominator is having everything in integer exponents, and right there you have it. Okay, so we are done. Now the next example is different because it's multiplying by the conjugate, and if you remember what we did in class, well, we did some conjugate questions. So the conjugate of this would be 2 minus square root of 5. Okay, so let's multiply the top and the bottom with 2 minus root 5, 2 minus root 5. Now you can use FOIL or you can use the special product, but right now, as I realized that we did not do special products, we can just do 5. So that would be 4 plus 2 root 5 minus 2 root 5 minus root 5 times root 5. That's in the bottom. And on the top you have 4 times 2 minus root 5. And you can see that these two are the same quantity, plus and minus, they cancel off. And root 5 times root 5 is just 5. So what you have is 4 times 2 minus root 5 divided by 4 minus 5. And 4 minus 5 is negative 1, so 4 times 2 minus root 5 divided by negative 1. And dividing by negative 1 is same as multiplying by negative 1. So what you can do is take out a negative sign, or you can simply flip it. Okay, so let's see how the flipping works. It would be just 4 times root 5 minus 2. Done. So now if you're wondering about what happened here, what I did was I took out a negative sign, negative 1 times 4, and then I flipped it, and this negative 1 was in the bottom, and then I cancelled it, and you get it. This might probably be, this and the lecture 3 would be the longest lectures, lecture part 2s, and then it will be shorter and shorter. So I'm really sorry if this thing is taking longer for you guys. Let's quickly do one more rationalizing the denominator example. That would be 3 plus 2 root 7 divided by 3 plus 2 root 7. So on the bottom you will end up, if you can FOIL or you can use a special product. Now here I'm going to just use a special product. It's just more convenient. You get 9 minus 28. You can FOIL it and see for yourself if you want further elaboration. 2 plus 2 root 7, and that would be negative 19 over 2, 3 plus 2 root 7. You can just bring this negative sign, so you get 2, negative 2, 3 plus 2 root 7 divided by 19 as your final answer. So one last thing, rationalize the numerator. It's very similar to rationalizing the denominator. The only thing is you should get a rational number on the top. So let's do this quickly. Multiply the top and the bottom by root 3 minus 2, root 2, root 3 minus root 2. And then use the special product. Root 3 plus root 2 times root 3 minus root 2 is 3 minus 2. Over 7 times root 3 minus root 2. So you end up with 1 over 7 times root 3 minus root 2. So now you have the numerator to be a rational number. So that's what we mean by rationalizing the numerator. Once again, I'm really sorry for this long video. There is one question at the end of this section, so please do the question and let's go to the next, the last section. Okay, so let's simplify these exponents, exponential expressions. Now, negative 125 is negative 5 cubed, and 8 is 2 cubed to the power of negative 2/3. What you can do here is switch it and make the exponent positive. So I can do 2 cubed over negative 5 cubed to the power positive of 2/3. Again, this is not the only way to do this. You can do it a different way, but that's what you have. Now you should be able to distribute this here and here. So you would end up getting 2 to the power 3 times 2 over 3, and again negative 5 to the power 3 times 2 over 3. So you can see that things cancel off, and you get 2 squared over negative 5 squared, that is 4 over 25. Negative 5 squared is plus 25. Okay. And then, let's look at this one. Again, I would make the outside exponent positive by flipping the whole thing. So, I don't do anything here. I would get x to the 4, 64, x to the power negative 8, and that would become positive. So I flip the inside and make it positive. So I'm just outlining different methods of doing these questions. Now you can actually distribute this guy right here, 1, 2, and 3. And also I will write 64 as 2 to the power 6. Okay, so let's see what I get here. X to the power 4 times 1 over 4 divided by 2 to the power 6 times 1 over 4 times x to the power negative 8 times 1 over 4. So I end up with x to the power 1, 2 to the power 3 over 2, and x to the power negative 2. And then I can move this x to the power negative 2 up. That would be x to the 1, x to the 2, over 2 to the 3 over 2, x3 over 2 to the 3 over 2. Now, in this case, I did not ask you to rationalize the denominator or anything. So the answer x to the power, answer x to the 3 over 2 to 3 over 2 would be there. That would be the final answer. Okay. And the last example, there are 2 more examples. So here I would just distribute this 1/5 to these 2 exponents. So I'm going to end up with 3/5 y to the negative 2/5 and x to the negative 2/5 y to the 3/5. So if you can see a negative exponent, move it to the other side. So I can see the negative exponent here, I would move it to the top. So 3/5 x to the 2/5. That guy goes to the top. And then this guy will come to the bottom because it has a negative exponent. So you get 3/5 that was already there, and y to the plus 2/5 because it came to the denominator. And now you can add the exponents, so x to the 3/5 plus 2/5 and y to the 3/5 plus 2/5. And you can see in both cases you get 1. So the answer ends up being simply x over y. And this is a very common phenomenon in this class. You can see a very complicated expressions. If you do it correctly step by step, you should end up with a very simple answer. Not always, but most of the time. And the last example, again, will illustrate that fact. Okay, first of all, you can see that these exponents are the same. So here what I'm using is a to the power n b to the power n is the same as ab to the power n. That is one of the rules that we learn in class. So if the exponent is the same, you can multiply the base. So what I do is, I will multiply the base with the same exponent, root 2 plus 1. So what I get is 5 minus root 3, 5 plus root 2. And you can FOIL this. Again, because we did not come to special product, let's FOIL this. So 25 minus 5 root 3 plus 5 root 3 minus root 3 times root 3 is 3. And also keep track of the exponent. And also there was something else here. You have to bring it forward. So 22 1 minus root 2, 22 1 minus root 2 is still there. So you can see that these two cancel off and you end up with 25 minus 3, which is 22. So what you have here is 22 to the power root 2 plus 1, and then 22 power to the power 1 minus root 2. And in that step, you can see the base is the same, therefore you can add the exponent. So let's write one base, 22, and add the exponent, root 2 plus 1 minus root 2. And now you can see that these two goes off and you get 22 squared. Well, without a calculator, I will not expect you to figure out what 22 squared in a minute, but just let's have it that way. So this is the end of the lecture part 2, and check out for lecture part 3 in the future.